Exercise 4B, question 5. Okay, we've been given a function, it's a fraction. We've been asked to prove that if x is sufficiently small, f of x may be approximated by. So the first thing they want us to do is to comment that a small value of x means we can ignore higher, x cubed and higher. Okay, I'm going to have to write the x cubed in just to save a bit of time. We can ignore x cubed and higher powers. Now you can see why I typed the first bit. Okay, so then a quick statement to that effect. Obviously, why can we ignore x cubed and higher? Well, if you put a very small value, so 0.2, cube it gets very small, okay, and would only affect very low decimal places. Okay, so it would give you a good approximation. We've seen that in previous questions. So, as usual, take your question and pop it in the form so you can see what you're working with. If I pop that up, I would have 3 plus 2x minus x squared to the 4 minus x to the minus 1. Now we can't multiply this out because there is a power on that second bracket. So the first bracket's fine, there's no power on that. They've been reasonably nice to us, so we only have to do one expansion, but do expect questions where the power is at the top as well. So I'm going to leave that be, it's absolutely fine, and I need to multiply out that 4 minus x to the minus 1. Okay, you can multiply polynomials very, very easily, guys. You cannot divide them, which is why I am not trying to divide that, because I want an expansion for it. I want an approximation, not just to simplify it. To caveat that, when I say you can't divide polynomials, you can. Obviously, there is algebraic division, but it gives you an equivalent form, not something you can use as an approximation. Okay, the reason we like this is because I can reasonably easily with mental arithmetic take x and then x squared and do it in my head. The idea of all these methods is they were there before the calculator. So, okay, I am going to take my 4 minus x to the minus 1 and I'm going to expand that. That is not a 1, so I am going to factorise out the 4 to the minus 1 to leave 1 minus x over 4 to the minus 1. Okay, so there's my power, there's my x. You'll notice I was, excuse me, include the x to the minus when I circle that part because it is important, you know, it needs to be there. So that equals what? 4 to the minus 1 is a quarter. 1 plus n x plus n minus 1. Okay, you give me 1 second. Let's try that again. Occasionally my notebook system likes to add random lines. Let's see if we can try that again. Minus x over 4 plus n minus 1 over 2 factorial, or 2 for simplicity's sake, minus x over 4 plus, don't need the rest. Okay, right, so I'm actually going to multiply this out in one go because it is relatively simple, because the great thing about minus 1 powers is that that cancels with that. Okay, oh, I've lost a square. Hope those of you that were watching spotted that. And I can multiply this out very, very quickly in my head. It's very straightforward to do. I have got, thank you, computer. I have got a quarter plus, because 2 minuses make a plus, x over 16 plus x squared over 64. Okay, now if you wanted to do that in 2 stages, so just the bracket first and then times by a quarter, that's absolutely fine. Okay, so now I've got my expansion for that. What we have to do is multiply it by the 3 plus 2x. So 3 plus 2x minus x squared times my quarter plus x over 16 plus x squared over 64. Okay, so right, when I multiply this out, I am not going to write down anything higher than x squared. Okay, so I'm only going to do some multiplying out. And to make my life easier, when I multiply this out, I am going to do it on separate lines and stagger it to make life easy. So let's start with 3. Now 3 will multiply every term. Okay, so I'm going to get 3 quarters plus 3x over 16 plus 3x squared over 64. Okay, now when I take the 2x, however, I'm only going to multiply it by those two because x times x squared is x cubed and I don't want it. Now rather than write it on the next line, to make my life a little bit easier, I'm going to do 2x over 4, sorry, just losing track of which one I was multiplying, plus 2x squared over 16. And you'll notice by lining it up like this, it takes a little bit of room on your paper, but it does make it an awful lot easier to add up. Do just put it on one line if you want. I am not going to add the next term, so last but by no means least is that one times that one. So that's minus x squared over 4. Add them all up, 3 quarters plus, now 3/16 plus 2 quarters is 11/16 of x plus, minus, get the sign right on this one. If I take 3 over 64, 2 over 16 and take away a quarter, I get minus 5 over 16x squared, which should miraculously appear in 3, 2, 1 x squared. Okay, right, let's just neaten up the random extra line. I think my poor computer is going on strike. Okay, and wait a minute, not 5 over 16. Can't read my own calculator. 5 over 64. Right, go back up and check. Yeah, 3 over 4, 11 over 16 minus 5 over 64. And I even spotted the error before I checked. Of course, always do double check. A really nice question, that one. Hope you enjoyed it.